The report has been made of scientists observing negative time in a quantum experiment. At first glance, this may sound like scientists have observed time travel. However, before you order your flux capacitor, that is not what they accomplished. Sorry for those who were really hoping for time travel, but this experiment does not demonstrate that. Nothing actually went back in time. The effect is nothing more than wave mechanics in action. In fact, there's no actual form of time reversal. What is happening in these experiments is purely a form of wave phenomenon. It is somewhat similar to quantum tunneling. Wave packets are a combination of multiple waves, then interfere into a narrow range. In quantum mechanics, one of the consequences of this, there is a relationship between the uncertainty in the wave number and the length of the wave packet. As a result, the smaller the width of the wave packet, the more uncertain the wave number is. This uncertainty is not a measuring problem, but rather it is fundamental to how quantum mechanics works. There is also one of the keys to the so-called negative time measurement. All wave packets have two velocities, group velocity and the phase velocity. They are not always the same and in fact can be the reverse of each other. This is also one of the keys to understanding its so-called negative time measurement. What is actually happening is that as the leading edge wave packet interacts with the target, there are absorptions and readmissions of photons that push the phase of the waves forward. The result is that the peak of the exiting wave packet emerges before the peak of the entering wave packet enters the target. This still image clearly illustrates what is going on. How this produces a negative time is that the time where the peak of the initial package enters the target is defined as time 0. Consequently, any time prior to that is a negative time. It is not backwards time, but simply prior to time 0. This is no different than a number line, where you have a 0 and everything before it is negative. This does not mean that you are going backwards, nor does it imply negative space. It is simply a matter of mathematics and where the 0 point is placed. If you place the 0 point time at the point where the secondary wave packet emerged, then there would be no negative time. The experiment consisted of a series of mirrors and electronics that allowed the experimenters to determine precisely when the peak entry of the initial wave packet entered and the emergence of the secondary wave packet. This was critical to being able to make the observation and demonstrate the so-called negative time effect. Consequently, there was neither time travel nor any causality problems. There are no issues for special and general relativity. This is simply wave mechanics in action along with what is an arbitrarily selected 0 point in time. All is still right with the universe. In conclusion, sorry to science fiction fans, no time travel was involved in this experiment. It is simply another example of quantum weirdness resulting from wave mechanics and the probability of finding a photon in a given spot in that wave packet. There's only something here to get excited about if you are a physicist interested in quantum mechanics.